Alright, so this is the next kind of stoichiometry problem. There are 4 kinds that you're going to learn, and so last one was mole to mole, and this one we're going to do mole to mass. So X to Y. So you're starting with one compound and you're going to a different compound. And that's something that's different about stoichiometry than what the conversions that you did. So before, a couple weeks ago when we did conversions, you were going from like grams of water into moles of water, but it was staying water. And this time we're converting from moles of one compound into the mass of a different compound. So these are 2-step conversions. So before now, all the problems that you've been doing have been one conversion. So they have 1 division bar, and now we're going to add on 2 division bars. And it actually gets to 3 as well. So that's the harder ones, the mole to mass, or sorry, mass to mass. And so with mole to mass, we're going to be using 2 division bars because we need to do 2-step conversion. And you'll know that you need to use the 2 division bars because you are going from moles to mass. And we'll also do mass to moles. That's the next one. Moles to mass, mass to moles. Both of those use 2 division bars. If you go from moles to moles, like you did in the last assignment, then it is 1 division bar. And then eventually we'll learn mass to mass, which is 3 division bars. But today we'll be going from moles to mass, moles of one compound into mass of a different compound. This is a stoichiometry map, and I think this helps some people and confuses other people, but here is how this works. So in last assignment, we were going from moles of A into moles of B. So moles to moles. And if you see, we only have to cross 1 arrow to get there. Moles of A into moles of B, and then we're using a molar ratio to get there, which is the balanced equation. Okay, so moles A's to moles B, molar ratio. That was the last kind of stoichiometry. So today we're going to be going from moles of A into grams of B over here, moles to grams. And so if you look, we have to go first from moles of A into moles of B. There is no direct path between these two here. You have to go through moles. Moles is like the bridge you have to cross. It doesn't matter what kind of problem you're doing, we always have to go through this section right here. So we start with moles of A, we're going to convert to moles of B, and then once we have moles of B, then we're going to convert to grams of B. So this is why you need 2 division bars, is because we have to do this conversion and then we have to do this conversion, and there is no direct path between these two, so we have to do these steps. So that's why it's going to be 2. And then you can see that we can also go backwards, so we can go from grams of A into moles of B. That's the one we're going to learn next. So we go grams to moles and then moles to moles, so that's 2. And then the third one is grams of A, 2 grams of B. But see how there's no direct path, so we have to go 1, 2, 3 steps. So I don't know if this chart helps you or not, but it kind of shows why we have to do what we do. So today we'll be going from moles of A to grams of B, going through these 2 steps here, molar ratio, and then also bringing back the molar mass. It's been a while since you've had to calculate a molar mass, so hopefully you still remember how to do that, because we will use molar mass here in our conversions. Alright, so you have an example problem here, and I'll just do it off the worksheet instead of off the PowerPoint so I can write on this thing here. You will need a periodic table. I did link one of those in the assignment page. It might be worth your time if you have access to a printer to print a periodic table. It might make your life a little bit easier, but you can always work off one on the internet as well. So let's start by balancing the equation, because that is always going to be step 1, is to balance the equation. So let's do black. Alright, so again, if you do not have to write these out, like you're at the point in your life where you could look at this equation and you could balance it just in your head, then you do what works for you. You do not have to write these out. It's just, I know a lot of people still need help with those equations, so if you still need help balancing equations, then it is definitely worth your time to write these out, because you are more likely to balance them correctly, which is ultimately what we want, even if it takes you a little extra work to get there. Alright, so write those out, and then we count. So we have 1 Ca, 2 Cls, 1 Na, 1 NO3. And then over here we have 1 Ca, 1 Cl, 1 Na, 2 NO3s. Alright, So I'm going to do the NO3s. I always start with either metals or polyatomics, and NO3 is a polyatomic. So you put a 2 here, that will give you 2 NAs. And that will also give you 2 NO3s here. And then next I want to balance my NAs. So I've got 2 here and 2 here. So then next I usually go to metals, and Na is a metal. I put a 2 here and a 2 here. And then it's balanced. Alright, so the next step, and always the first step of a stoichiometry problem after balancing the equation, is to write your starting amount. And if you can just remember these kind of basic steps, it does make your life like a lot easier in the end, because then you're not like, oh, it's this kind of problem, what were the steps for this kind of problem? Like, the steps are always generally the same. Always start by writing what you have, okay, for every kind of stoichiometry problem. So I have 3.50 moles of CaCl2. Alright, then the next step is always going to be the same as well. So step 3, draw a division bar. There we go. Now the next step is always going to be the same as well. Take what you have and put it on the bottom. So take the units that you have, moles of CaCl2, and put it on the bottom. This is what you do for every stoichiometry problem. This is what you do for every conversion problem. These should always be diagonal to each other. Sometimes you know, people do like this, where they do a bracket and they, you know, it's top, bottom, or whatever. Like, do whatever works for you. I find this works a little bit easier for me, but, you know, do whatever works for you. So I put my unit that I want on the bottom, and then what goes on the top is moles of what you need on top. So what they asked me for, I have 3.50 moles of CaCl2, how many grams of NaCl can I make? So I'm looking for grams of NaCl. So, but I don't put grams of NaCl on the top, because I can't go directly 2 grams from moles of a different compound. I have to go through the mole bridge first. So I have to do moles of NaCl. So I have to convert from moles to moles, moles of one compound to moles of another, before I can go to grams. Like, you have to go through moles. So then, whenever you have mole over mole, this is where you go to the equation to get those numbers. Mole over mole, go to the equation. So CaCl2 has nothing in front of it, so that's a 1. And then NaCl has a 2 in front of it, so that's a 2. Okay? Moles over moles, go to the equation. Now, on to the next step. So fill in the mole numbers by looking at the balanced equation. We did that. Write a multiplication symbol, draw a division bar. So we add on here, next division bar. Okay? And then next step, calculate the molar mass of the compound you are solving for and write it on the top of the division bar. But even if I didn't read that, here's what you should do. Always take the unit on top and drop it to the bottom. These units should always be diagonal to each other. So this should be moles of NaCl. Okay, that way you don't have to memorize like what goes where. It's just always the rule. Units should be diagonal to each other. See, these units are diagonal to each other. These units are diagonal to each other. And then the unit that they asked you for should be your final unit on top. So this is grams of NaCl. And then in general, whenever I see grams and moles together, G and mole, when grams and moles are together, this mole is always 1. Always 1. Always. You hear me? This mole is always 1. It is not take this number from the equation. No. You only do that when it's moles over moles. When it's grams over moles, this mole is always 1. Okay? Always. So don't put any other number here. G and mole, this will never be any other number but 1. Because what it's telling you is 1 mole weighs this amount. And then I need to go to the periodic table to get G. So G always comes from the periodic table. So I've got Na and Cl. So Cl is 35.45, Na is 22.99. So I'm going to add them together, 22.99 plus 35.45. And then I get 58.44. 58.44. Alright, now I am done and I am ready to solve. So here is how you solve these problems, just like before. Don't complicate this. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Always. Multiply by the top, divide by the bottom. It's always going to be that way. So I have 3.50 times 2, and then the bottom number was 1. Okay, 7. 3.50 times 2 divided by 1. Now multiply by the top number, divide by the bottom. So multiply my 7 times 58.44, and then divide by 1. And I know that you don't have to divide by 1, it gives you the same answer, whatever, blah, blah, blah. But it is symbolic, because that is how you cancel those units, is dividing by that. 1, 409.08. Alright, so then for units, let me switch to red. Diagonal units cancel when you divide. Moles of CaCl2 cancels moles of CaCl2. Moles of NaCl cancels moles of NaCl. This leaves me with just one unit. It should always be your top unit, and that is going to drop after your problem. So this should be grams of NaCl. Alright, so I'll do a couple more and then I'll leave you a couple to do. So do our counts. So Ca, and then we have CO3, which is a polyatomic, but if I look on the right side here, there is no CO3. So this is a polyatomic that splits, which happens sometimes. If it's not on both sides, then you don't count it as a polyatomic. So Ca is 1, C is 1, O is 3, and then over here Ca is 1, and then C is 1, and then O is 3, because there are 2 here and 1 there. Isn't it nice? That's balance. We don't have to do anything else. So start by writing what you have. Always start by writing what you have. Doesn't matter what kind of stoichiometry problem it is, just start by writing what you have. And if you can just start the problem, then you can probably work your way through it. But sometimes people are just like, I don't know what to do. Start by writing what you have. I have 5.00 moles of CaO. Next step is always going to be draw a division bar. It doesn't matter what stoichiometry you're doing, that is always the same. Okay? Take your starting unit and put it on the bottom. Alright, so then I put moles of CaO on the bottom. Now, I want to go to grams of CaCO3. That's what they asked me for, but I can't go directly to grams. You can't. It doesn't work. You can, however, go to moles of that compound. Okay, so moles of CaCO3. I need to go through moles first. Moles is the bridge that helps me cross to the other compound, and that's because of the balanced equation. So then, when you have moles over moles, that's where you go to the equation, and all of the coefficients were 1, so this is going to be 1 here. Moles over moles, go to the equation. And then, you take your unit on the top, and you move it to the bottom, always. Moles of CaCO3. Okay, and then the final unit I want is going to be on the top, so this would be grams of CaCO3. Alright, you know that when grams is with moles, this mole is always 1. Nothing else other than 1. Always 1. And the grams is going to come from the periodic table, so I need to get the mass of Ca and C and O times 3. So 40.08 is calcium. And then CaC, carbon, 12.01, and then O3 is 16 times 3, 100.09. Now you solve. Multiply by the top number, divide by the bottom. Multiply by the top number, divide by the bottom. So this would be 5 times 1, which is 5, divided by 1, which is 5, times 100.09, I'm going to get a calculator that, 100.09 times 5, 500.45, divided by 1 is still 500.45. So 500.45. Okay, now I go back through with my canceling. Moles of CaO should cancel its diagonal, which should be moles of CaO. Diagonals should always match. Moles of CaCO3 should cancel its diagonal, moles of CaCO3. The unit that's left should be this one on the top, which then gets dropped behind your answer, grams of CaCO3. and this better match what they asked you for, which is grams of CaCO3. If it doesn't, you did something wrong, or you're solving for the wrong thing. They asked for grams of CaCO3, I gave them grams of CaCO3. So that's what you want to do in your problem. Alright, here I got Mg, and then Ag, and then I have NO3, which stays together on the left and the right side, so I'm going to count that as a polyatomic. And write the same thing over here, Mg, Ag, NO3. And then do your counts. Mg is 1, Ag is 1, NO3 is 1. Over here, Mg is 1, Ag is 1, NO3 is 2. So the only thing not balanced is the NO3. I'm going to put a 2 here. This is going to give me 2 Ags, and then also 2 NO3s. And then I need to balance my Ags, so I put a 2 here. This becomes 2. Now it's balanced. Start by writing what you have. 0.50 moles of Mg. Draw your first division bar. Take your starting unit, put it on the bottom. Moles of Mg. And then your unit that you need to go into is going to be moles. Okay, I have to go through moles first, but it says moles of, oh, here's a tricky one. Alright, you gotta read these carefully. So they gave me this as my starting amount. But then if I look here, they list AgNO3 and also Ag. And so you have to read carefully to figure out which one you want, because if you pick the wrong one, you'll get the wrong answer. So it says moles of Mg reacts with AgNO3. It's just like narrating the equation here. Mg reacted with AgNO3. How many grams of Ag are prepared? So I'm not looking for AgNO3, I'm looking for Ag. And so you need to read carefully to figure that out. This is the one I want because they asked me for grams of this one. This one is just like, hey, there's some information there I don't really need, but you know, that happens. So all I want is the Ag. I don't want the AgNO3. And you can't convert 3 compounds. Like, there's no stoichiometry where we do Mg and AgNO3 and Ag. Like, that doesn't happen in any stoichiometry. It's always from one compound to another. So this time I'm going from Mg to Ag. So I start with moles of Mg, and then I have to turn that into moles of Ag, because moles are the bridge that I have to go through. And here I have moles over moles, and anytime you have moles over moles, you now know you go to the balanced equation for that. So in front of Ag is a 2, and in front of Mg is nothing, so that's a 1. Second division bar. Take your moles of Ag, because that's not what they asked me for. They want grams of Ag, so I still need one more step. Moles of Ag. And then I want grams of Ag. When you have moles over grams, just as a hint here, when you have moles and grams together, these compounds better be the same. You cannot have grams of something with moles of something else on the bottom. You just can't. The only time you can have 2 different compounds across from each other like this, Ag and Mg, is if they're both mole. That is the only time. If you see like moles and grams and it's one compound and the other one, like if I did, you know, grams of Ag and moles of Mg, then you did something wrong. Grams and moles always has the same compound next to them. Always. That's a little hint there for you. And then you also know that grams and moles, this mole is always going to be 1, and this grams comes from the periodic table. So Ag here is silver, 107.87. I don't have to do any math there because it's just a single compound, or a single element, 107.87. Now I solve. Always multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. So 0.5 times 2 is 1, and then 2 divided by 1 is 1. And so I'm still at 1, and then 1 times 107.87 is still 1, and then divided by 1 is still 170.87. So 0.5 times 2 is 1, 1 divided by 1 is 1, 1 times 107.87 is 107.87, divided by 1 is 1, is 107.87. So the answer is 107.87. Alright, then I want to do this canceling thing, and if you forget to do this, then, you know, that's at your own peril, because this is a chance to check to make sure you actually like set these problems up correctly. Diagonals should match. Diagonals should match, and if they do, you did that correctly. If they don't, you did it wrong. Diagonals should always match each other. Moles of Ag here should match moles of Ag here. I should have my final unit that they asked me for on the top. Grams of Ag. Stoichiometry is all about units and all about canceling units, and so you always have to write the units, and the units are the whole reason we're doing this. So you can't just put in numbers here. If I ever see a stoichiometry problem and you did not put in the units, I will not give you credit for that. All right, hopefully that is enough to get you started, and now I'm going to leave you with the next 5 problems on your own.